So now our next topic will be making out of chaos, and this making out of chaos is nothing but it is a modern periodic table. Now, why I have used the term making out of the chaos? Because when different scientists tried their different attempts for the construction of the periodic table, like Daubernier law of octaves, then Mendeleev's periodic table, and finally moving out from all the chaos, we have generated a modern periodic table that we are studied now. So let us have a look at the modern periodic table. So this is our modern periodic table. I can rub from here so it might be visible to you. This is our modern periodic table, and you can easily see that it is a long form of the periodic table. This is actually a long form of the periodic table that we are seeing here. Now you can easily see that the 1, 2, 3, 4, 5, 6, 7. These 7 lines that are horizontal rows are known as periods, and the groups that are divided vertically, that is from counting from 1, this is 18th group. So the vertical columns are termed as groups. So let us discuss about some of the characteristics of both periods and groups. So our next topic will be general description about horizontal rows that are called periods. Now we will consider the points one by one by looking at this table only. So you can see that in this periodic table there are 7 horizontal rows, and these 7 horizontal rows, that is 1, 2, 3, 4, 5, 6, 7, are termed as periods. So the first point I can write here. Horizontal rows are called periods. So the horizontal rows are known as periods, and there are 7 periods in the periodic table, that is in the modern periodic table. Second point we are considering here is 7 periods named as 1, 2, 3, 4, 5, 6, 7. These 7 periods can be named as 1, 2, 3, 4, 5, 6, 7. So this is the another point we are considering here. The 7 periods can be written like this. Now moving to our next property, it means each one will having a outermost shell present in their atom. So we can see that outermost shell will be available for each period. So the next point will be each consists of outermost shell. So this is the next point of consideration, and you can easily see that the periodic table that is starting from periods having a general electronic configuration NS1. NS1 means in the S subshell 1 electron can be minimally filled. So the next point we are considering here, each will start with, each means each period is going to start with alkali metals. You can see that the first group that is present here are known as the alkali metals, because these will have a property to form the bases easily. So each will start with alkali metal having NS1 electrons. So this is the next characteristic of the period. Now this table is starting from NS1. You can see here this table is starting from alkali metals. These are actually alkali metals. So we can see that this table has been starting from alkali metals having electronic configuration NS1, and moving along the periods we can see that this table has been ended to the 18th group element. This is our halogens. So these are halogens, these are actually noble gases. These are our noble gases, group 18 elements. These are noble gases. So you can see that the periods are actually starting from alkali metals and have been ended to the noble gases, and the noble gases have their outermost shell fully filled, so it is having a general electronic configuration NS2np6. So we can say that starting with alkali metals, it ends with noble gases. It is ending with noble gases, and noble gases is having a general configuration NS2np6. But you can note here there is one exception, that is helium. Helium is having a electronic configuration NS2. So helium will not be counted in the category of NS2np6. So exception here will be, what is the exception here? The basic exception here will be helium. Helium is having an electronic configuration NS2, but apart from it, all the other metals is having an electronic configuration, that is NS2np6. So these are some of the characteristics that I have written for the periods. Now we are having a 7 periods in the periodic table. So these will be divided into subshells. So the first period in the periodic table is known as a very small period, because it basically consists of 2 elements only, that is hydrogen and helium only. So let us move to counting the number of shells or the subshells in the periodic table. But firstly, copy this characteristics from here. So now let us move to the some of the few characteristics about the modern periodic table. So we can write here. In this characteristics, we have one more characteristic, that is each subshell will start filling a new energy level. So this will start filling with a new energy level. Now you can see that we will count the number of the periods in this periodic table. So we have our first period. So we can say that first and second periods in the periodic table are known as, first and second period in the periodic table are termed as very short period. These are known as very short period. Why it is called very short period? Because it consists of two elements. And what are these two elements? These two elements are hydrogen and helium. So the first and second period will consist of only 2 elements, because 2 elements or the 2 electrons can be accommodated in it. So the first period is known as very short period. Now the third and the fourth periods are known as short periods. So let us move to our next category, that is third and fourth periods. So the third and fourth period of the periodic table is termed as short period, and This short period will accommodate maximum of 8 elements or the 8 electrons. We can say that it consists of eight elements. So it usually consists of 8 elements. So the 8 elements will going to start from lithium to neon, and from sodium to potassium. Lithium will having atomic number 3 and it is having atomic number 10, and sodium is having number this 11, and it is going to end after before that magnesium, aluminium, magnesium, silicon, sulfur, and it is going to end on potassium. It is going to end on potassium. Now let us consider our next group, that is fifth group. So we can write the elements here. So we know that each subshell will going to start with the filling of new energy level. Now let us discuss about the periods, that is first period of the periodic table. So the first period of the periodic table is known as very small period. Why it is known as very small period? Because it usually consists of only 2 elements, that is hydrogen and helium. So this period is known as very short period. It is called very short period because it usually consists of two elements. Now let us move to our second period. We are considering second and third period. These are known as so let us move to the second and third period. Second and third periods are usually termed as short periods. This is our first period, which is actually very short, and second and third periods are known as short periods. So in case of the second and third periods, we can see that it consists of 8 elements. And what will be the range for these elements? These will starting from lithium to neon. Lithium means atomic number 3 and neon means atomic number 10. And this period is going to start with sodium, that is Na11, to argon having atomic number 18. So this will be the general configuration for second and third period. Now moving to our next period, which is known as a long period. So the third category we have is fourth and fifth periods. So fourth and fifth periods in the periodic table are known as long periods. These are known as long periods. Now, what does this long period going to specify? Long period means that they will constitute 18 elements in the periodic table. So, it usually consists of 18 elements. So, what will be the range of these elements if it is going to form the 18 elements? So, the range is going to start from potassium to krypton, and secondly, it is going to start from rubidium to xenon. So, this will be the range of 18 elements in the periodic table. Now, let us consider the sixth period. Let us consider the sixth period in the periodic table. The sixth period in the periodic table is usually termed as a very long period. Why it is known as very long period? Because it usually consists of 32 elements. It consists of 32 elements. So, among these 32 elements, it is going to start from cerium to lutetium and cesium to Rn. So, these elements will going to start from cesium to radon and cerium to lutetium. Now, let us consider our next category, that is period number 7. Period number 7, and among these the 14 elements are going to be considered of the lanthanoid series. So, we can see that 14 elements will going to form lanthanoid series. Now, considering period number 7, this period usually consists of 25 elements. It consists of 25 elements, and among these 25 elements, 14 elements is going to belong to the actinoid series that you have observed that lies in the bottom part of the periodic table. So, among these 14 elements belongs to actinoid series, and for this reason that it consists only 25 elements, the name of this period is incomplete period. The name of this period will be incomplete period, and the element it comprises of will be, so these elements may be start from thorium to lawrencium, and it may start from francium to Rg. This is thorium, this is lawrencium, this is francium, and this is the new element, that is the atomic number 111, that is rogentanium. So, this is rogentium. So, these are the elements of the periodic table. Let's have a brief look at all of these periods. The first period consists of 2 elements. For this reason, the first period is known as very small periods, and the 2 elements are actually hydrogen and helium. Moving to second and third period, second and third both the periods are known as short period, and it consists of the 8 elements. It means 2, after that 8. Now, long period is going to constitute 18 elements. 18 element are present, so it is known as the long period. Sixth period is known as very long period, and in this the 14 elements actually belong to the lanthanoid series. So, very long period because of it is going to form the 32 elements. Now, the last group, that is the 7th group, is actually known as the incomplete group, and out of this 25 elements, 14 elements are again going to belong to the actinoid series. So these last two periods are actually for lanthanoid and actinoid series. Now I hope this has been clear to you. Now you can see that if we are going from left to right in the periodic table, it means if we are going along the periods, the properties are not same because the valence electron present in an atom is not same. So we can say that along the periods, the physical and chemical properties are not same. So one more point I am considering here, I am rubbing this part. So we can write here. So this can be a note you can write here. What note we are observing here, that along the periods, if we are going along the periods, we can say that valence electrons are not same. Valence electrons are not same. As the number of valence electrons are not same along the period, we can say that along the period, physical and chemical properties are actually different. Physical and chemical properties are different. So this will be the point of consideration here, that along the period, the physical and chemical properties of the elements will not be same. These will vary. Now, this is all about the periods we have considered here. Let us have a general tabular description about this period, so it might be clear to you that how you have to remember the such kind of the periods. Now, we will make a tabular description of such kind of periods. So we can write here description about periods. So we will draw a table. Here we will write the value of n. Here I am going to write number of electrons. Name of period and number of period. So this table will give you a general description about all the periods. Now, what we are going to substitute the value of n? N will be equal to 1, 2, 3, 4, 5, 6 and 7. These are actually the values of n. Now, the number of electrons, if I am starting from very short period, it is the first period we have. We have first period, second period, third period, fourth period, fifth period, sixth period and seventh period. Now you can see that what is the name of the first period we have seen? The first period is known as very short period. The name of the first period is very short period. And how many electrons or the elements it can accommodate? It may not be number of electrons, it may be number of elements. So how many elements it can accommodate? It can accommodate maximum of 2 elements. So the name of the period is very short period. So it is 2. Now, moving to our next category, we have second period. Second and third period both are known as short period. These both are known as short period. So, how many elements will be accommodated in a short period? The short period is going to accommodate 8 and 8 elements in both. It will constitute 8 and 8 elements. So, this is the value of n equal to 1 here. We can draw it like, we can draw here n equal to 1, n equal to 2 and n equal to 3. Now, for value of n equal to 4. Now, consider fourth and fifth period. What is fourth and fifth period called? They both are called long periods. So, I can write here, these both are long periods. These are long periods. In this long periods, we can say that the maximum electrons or the maximum number of elements it can accommodate are 18 and 18. So, these will be value for n equal to 5 here. Clear? These are known as the long periods. Now, let us consider the sixth period of the periodic table. Sixth period of the periodic table is known as very long period. This is known as very long period. Why it is known as very long period? Because it can accommodate maximum of 32 elements, and here n will be equal to 6. Here value of n will going to specify the numbers only. Now, n equal to 7. After very long period, we have the last period, that is incomplete period, and the elements in the incomplete period are actually 25. So, you can see that from this table, it is how much easy to learn the number of very short period, long, incomplete period or very long periods. So, you can draw this table. So, if you are going to revise again, it may be easier to you to get the help of the periods. So, copy this table from here. This is all about the description of the periods we have seen here. Now, we are left with the description of the groups. So, now we are going to discuss about the description of groups only. So, students, let us discuss after the periods about the description of the groups. So, let us have a look at the modern periodic table. This is our modern periodic table, you can see here. Now, we are going to discuss about the general description about groups. We are going to discuss about general description of groups. Now, you can see in the periodic table, if I am going to count the vertical columns are termed as the groups. So, we can say that the vertical columns are known as groups. So, what are groups in the periodic table? The vertical columns are actually known as groups. So, this is the first point. And you can see here, we can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and this number is 18. So, you can count here, there are 18 groups in the periodic table. The vertical columns that are that we have seen here are known as the groups in the periodic table. So, the groups are, number of groups are 1, 2 and up to 18. So, now what will happen here? This modern periodic table is accepted worldwide by IUPAC only. It is first standardized in the US, except certain elements are not known, but yet it is accepted because it contains maximum of the elements. So, it is accepted worldwide by IUPAC. So, it is accepted by IUPAC. and IUPAC is International Union of Pure and Applied Chemistry. Now, you can see that what is the basic similarity between this kind of the groups. So, we can say that if we are moving down the group, the properties of the elements will be similar because the number of the valence electrons are similar for a particular group. Suppose if I am considering the group number this, so it will contain the 3 electrons in the outermost shell. It means same electrons in the outermost shell. So, the number of valence shell electron in case of the groups are same. So, the groups are having similar physical and chemical property. So, the another point we can draw from here is number of valence electrons for a group is same. If the group is having a similar number of electrons, it means it will exhibit the similar physical and chemical property. So, we can say that similar physical and chemical properties are for group. But what we have discussed in the case of periods, in case of the periods, if we are going along the periods in 7 periods, we see that the physical and the chemical properties are entirely different. But what happens in case of the groups? Groups will constitute the similar physical and chemical properties. Now, you can see here, these two rows are separated from the periodic table. These are actually the lanthanoid and the actinoid series. Now, you can see here, there are 2 lines, 1 and 2. This first line is known as alkali earth metals and the second line is known as alkaline earth metal, and these two groups 1 and 2 is going to constitute the S block elements. So, what will be the name for these elements? These are actually, this 1 and 2 group will going to constitute S block elements. So, we can say that 1 and 2 group is going to form S block elements here. So, these are actually S block. Now, I am writing the description of the groups here. So, what is group number 1 called? Group number 1 is called alkali metals. These are alkali metals. And what is group number 2 called here? The group number 2 is called alkaline earth metals. Group number 2 is called alkaline earth metals. So, it is clear to you that group 1 and 2 will constitute the S block elements, and the maximum number of elements it can accommodate will be 1, 2, 3, 4, 5, 6, 7. 7 elements are present here. 8, 9, 10, 11, 12, 13. So, 7 plus 6 will give you 13. So, how many elements are present in this S block elements? So, we can see that 13 elements are present in S block elements. How many elements are there? There are 13 elements, and group 1 and 2 will going to constitute S block element, and group 1 is known as the alkali metal and the group 2 is known as alkaline earth metals. Now, further moving to the periodic table, you can see that this group 13, 14, 15, 16 and 17. These are the group from 13 to 16 and 13 to 17. And this is the group that is partially drawn here. It means it has been drawn in the end. Helium, neon, argon, krypton, xenon, radon, and that is 118 number has been given. It means it has not been discovered yet. Now, you can see that these elements in the green color will contain 0 number of valence electron in the outermost shell. It means they have their completely filled octet. So, these are known as noble gases, noble earth metals, rare gases, or we can say that they are known as Halogens. So, this is our group number 18. This is our group number 18. So we can write here group number 18. Group number 18 is having a 0 valence electrons. Group 18 will have 0 valence electrons. 0 valence electrons means its octet is full and it has a complete octet. So these gases are actually known as group 18 and known as noble gases, rare gases, or we can say rare elements. We can say rare elements. We can call them inert gases and we can also call them Halogens. So you can see here how many names we are representing for group 18 elements. They have the completely filled octet. It means 0 valence electron and these are counted in the category of the noble gases. Now you can see here the blue part. Fluorine, chlorine, bromine, iodine, astatine. You can see here, this is our group number 17. This is our group number 17 and group number 17 is usually termed as halogens. What is the name of these compounds here? These are known as halogens. So we can say that group number 17 is known as halogens. These are known as halogens. Now, moving to the further part of the table, you can see here the group from 3 to 12. That is in the yellow part and that is the horizontal part of the periodic table. This group from 3 to 12 is considered in the category of D block elements. What is this group called? This group from 3 to 12 in the middle part of the table is known as D block elements. These are D block elements and this group from here to here is known as P block elements. So you can see that the first and second group are our S block, then in the middle part is left and in the last, that is in the extreme right of the modern periodic table, we will get the P block and in the middle section we are getting the D block. So these D block elements are usually referred as transition elements. What are they called? They are called transition elements. These are called alkali or alkaline earth metals and these are going to be called representative elements. I'm again repeating, the part that is present in the extreme left of the periodic table is S block. The part that is present in the extreme right of the periodic table is actually P block and the part that lies in the middle of the periodic table is actually D block elements. Now, these D block elements are termed as transition metals. What is their name? Their name is transition metals. And this group is going to represent the representative elements. So we can say that this part and this part is going to represent representative and we can say that these are normal elements. These are normal elements. Representative and normal elements means group 1 and 2 and group from 13 to 17 are known as the normal elements and representative elements. Now, you can see that lithium, sodium and potassium, all of these will have a 1 electron only in their outermost shell. If the valence electron is 1, So it can be counted in the group number 1. So the number of valence electron will going to specify the name of the group, and the first element of the particular group is known by the name of that group only, and they will exhibit the similar properties along the group. Now let us move to the last two categories you have seen here. Now you can see that these are separated from the periodic table. It means these might have quite different properties from among these the elements. So these were discovered later, and these two series, that is lanthanoids and the actinoid series, are known as F block elements. What is the name of this series? This series is known as F block elements. This is our F block. And do you know what is the name of F block elements? F block elements are usually known by the name that is inner transition metals. These are transition metals and these are inner transition metals. So the name of the F block will be, I am writing it here, F block is known by the name inner transition metals. So the name of this F block will be inner transition. This is our S block, this is our P block, this in the middle part we have the D block, and in the last part we have our F block. So this is the description, that is the basic description about the group of the element and the groups and the periods of the periodic table. You might have to remember this step by step, so it might be easier to write the electronic configuration and to learn the trends in the periodic table. Now we know that there is one group present here, that is group number 15. You can see here. This type of group is known as Nicogens because it is used to form the toxic substances. We have group number 16 here, 15, 16, 17 and 18. 18 we have considered noble gases. These are halogens, these are Nicogens, and these are known as chalcogens. What are they called? They are called chalcogens. So I do not have a space here, so I am writing it here in the bottom part of the table. Group 16. Group 16 is known as chalcogens and group 15 is known as Nicogens. So you can see that these are the two another name for group number 16 and 18. 15 and 16. So these are Nicogens, these are chalcogens, these are halogens, and these are our noble gases, that are rare gases. So it is all about the brief description of the periodic table that we have discussed. Now moving to our next properties, we are going to discuss one by one about the description of these S block, P block, D block and F block. So let us move to our next topic. So before discussing about the general characteristics of the 4 blocks, let us have some of the merits of the modern periodic table, because in all the discussions, that is early attempts we have discussed before, we have gone through merits and demerits. So it is necessary to know about the merits and demerits of this modern periodic table. So before starting about the description of S block, P block and the D block elements, let us learn about some of the merits and demerits of the modern periodic table, because in the early attempts that we have discussed earlier, we have also gone through the merits and demerits also. So let us have merits and demerits of modern periodic table. So our next topic is about merits of modern periodic table. Now, what will be the first merit of the modern periodic table? First merit will be the anomalous pair of elements. We have seen that the earlier attempts that are showing some, when they are considered on the basis of the atomic mass, some atomic masses has been placed before. It means lower is placed before, higher is placed before the lower one, but it is not considered well, so it has been discarded. But you know that modern periodic table is actually based upon the increasing number of atomic number. It is not based on the atomic mass. So this point has been discarded by modern periodic table, and this correction has been made according to the anomalous pair of elements. So our first merit is anomalous pair of elements. So if I am considering the anomalous pair of elements, what we have seen here, we will see a tabular description here. Name of element, atomic mass, atomic number. Now first one, the name of the element will be argon and potassium. After argon and potassium we have cobalt and nickel. Then we have thorium and proctatium. Twice 28, 60, 59, 232, 231, 90 and 90. Now from this table you can easily observe how periodic table that was studied earlier show anomalous behavior. Now look at this table, you can see that if we are considering the atomic mass will be the fundamental concept of identify the periodic properties, you can say that argon is having a atomic number 18, mass 40. So if it is following the trend of atomic masses, the greater atomic mass 40 comes before 39, which is not appreciable. Now if I am considering cobalt and nickel, again 60 before, 59 afterwards, so it will not be considerable. Now if I am considering this thorium and that is Pa, what is Pa stands for? Pa in the periodic table stands for proctatium. This proctatium is having a mass 231. It comes before, but 232 greater mass will be considered before that. So you can see that if I am considering the atomic masses, this will not follow the trend. But according to the modern periodic table, this table is actually based on atomic number. So if this table is based on the atomic number, you can see that 18, 19, this is a correct point, 27, 28, 90, 91. So on the basis of the atomic number, this anomalous pair of elements are significantly fitted in the periodic table and corrected on the basis of atomic numbers. So these will be corrected. These are corrected in modern periodic table according to atomic number. Now let us move to the second merit of the modern periodic table. The second merit of the modern periodic table is about the positions of isotopes. So the second characteristic will be position of isotopes. Now let us rewind back to our previous topic, that what actually the isotopes are. Isotopes of the elements are those elements which is having a same atomic number but different atomic mass. So previously it has been a very important point that how isotopes has been fitted in the periodic table, because it is having a different atomic number. So what we needed a 3 spaces in the periodic table to fill such kind of the elements. So what happens further, isotopes is having a same atomic number but different atomic masses. So these atomic masses are not taken into the consideration, only same atomic number has been taken into consideration, and isotopes are given one place in the periodic table. So what are isotopes? Isotopes of the element are having a same atomic number. These are having a same atomic number but different atomic mass. These are having a same atomic number and different atomic mass. So if we follow the trend of same atomic number, that if we are following on the modern periodic table, atomic number is only 1 for the compound. If I am considering hydrogen, it is having a 3 isotopes. What are they? Protium, deuterium and tritium. All of these have atomic number 1 but the masses are different. So if we are going to arrange them earlier according to the atomic masses, these will needed a 3 spaces in the periodic table, which is not possible. So according to modern periodic table, according to modern periodic table, atomic number is same. So isotopes are given one position. So this will be given one position in the periodic table. So this is all about the position of the isotopes, which has been cleared according to the modern periodic table. Now in the modern periodic table, the elements with similar properties are placed together and having a dissimilar properties are discarded from the table. It means they are drawn separately in the table. So the next point we have is similarity and dissimilarity. So if we are going to consider about the similarity and dissimilarity, similar elements are placed together and dissimilar elements are separated. So similar elements are placed together and dissimilar elements has been separated from the periodic table. Now periodicity in the properties, that how the periodicity will occur in the properties of the element has been proven by the modern periodic table. So the next point is periodicity in properties. So the periodicity has been proved by modern periodic table. So these are the 4 merits about the modern periodic table. So firstly, copy these merits from here so we can proceed to what are the demerits of the modern periodic table. So please copy this from here. Now Let us move to the demerits of modern periodic table. I am rubbing this part from here. Now, the next topic will be demerits of modern periodic table. Now, basically, there are only two demerits left for the modern periodic table. It is fully completed, but yet it has not been tell us the reason for the position of the hydrogen. Position of the hydrogen is not justified, and the position of the lanthanoid and actinoids are not actually given. So, there are majorly two demerits of the modern periodic table. First one is, it do not tell us about the exact position of hydrogen. The position of the hydrogen is not specified, and position of lanthanoids and actinoids. So, these are the two drawbacks of the modern periodic table, that it will not justify the position of hydrogen and it is not justifying the position of lanthanoid and actinoids very briefly. So, these are the two demerits of the modern periodic table. Now, we are going to discuss about the characteristics of S, P, D and F block elements individually. So, let us start with the characteristics of S block elements. So, now our topic will be characteristics of S block elements. Now, you will learn the characteristic of the S block elements very easily, because if you know or if you have a clear picture of the periodic table in your mind, it becomes very easy to identify the properties. Now, let's have a look at some of the characteristics of S block elements. Now, firstly, when the outermost electron is going to be filled in the subshell of ns1 orbital. ns1 orbital, it means in S subshell, we can say that it will be the member of the S block element. So, what will be its first property? First property is, when outermost electron is filled in S subshell having ns1 electrons, we can say that this will be the elements of the S group only. Now, general electronic configuration for S block elements are, general electronic configuration for S block elements are ns1 to 2. It means it can accommodate maximum of 2 electrons. So, it may be either 1, it may be either 0 or it may be 2. So, the general electronic configuration for such kind of the elements will be ns1 to 2. Now, you have seen in the modern periodic table, the S block elements generally lie in the extreme left side of the periodic table. So, we can say that they lie in the extreme left of periodic table. So we can say that outermost electron will going in the S subshell having the general electronic configuration ns2 122 and they lie in the extreme left of the periodic table. Now you can see here in the periodic table, if they are lying in the extreme left, there are 13 elements in the X block. We have counted earlier that there are 13 elements in the S block. So in the S block, we usually have 13 elements. Now, next feature of the S block element is that they are generally metals. They are generally metals, but one exception is here, the hydrogen is not a metal. So one exception exists here, except hydrogen. Next characteristic of the S block elements are that it consists of the two groups 1 and 2 and they are known as alkali metals and alkaline earth metals that I have already told you, but once I am writing it here for your easier purpose. So group 1 and 2 are group 1 and 2 will constitute, we can write constitute term here, S block element. These two will constitute S block element and again group 1 is called alkali metal and group 2 is known as alkaline earth metal. Group 2 is known as alkaline earth metal. So these are some of the general characteristics of the S block elements. Now we have many more characteristics of the S block elements are, next characteristic we have the oxidation state. The oxidation state of S block elements is +1 and +2 generally. Generally the oxidation state of such kind of the elements is +1 and +2. Now they are soft metals. They are generally soft metals. The elements present in group 1 and 2 are considered as the soft metal. Next property, they form ionic compounds. They are going to form ionic compounds and they are reactive as well as. They are reactive. So here we have seen about a lot of characteristics of the S block elements. So you have to remember it line wise or you have to remember it step by step that what will be the characteristic of the S block elements. So I hope from the tabular description or the modern periodic table, it might be clear to you that what are the characteristics of the S block element. Now moving to our next group, that what are the characteristics of P block element. So firstly you can copy it from here. Now let us move to the characteristics of D orbital. So the next topic will be characteristics of D orbital. Now when the differentiating electron enters in the n-1 orbit of the D elements, we can say that it will be the D orbital element. So what will happen here? The differentiating electron the differentiating electron enters in n-1 d orbital of a atom. Next point of consideration about the d orbital is they lie in the middle part of the periodic table. They lie in the exact middle part of the periodic table. And we know that the general electronic configuration for such kind of elements can be written as general electronic configuration is, it is entering in the n-1 orbital. So, the general electronic configuration will be n-1 d this will be the general electronic configuration for. So, the general electronic configuration means it can accommodate maximum of 10. So, it can be written as n-1 d 1 to 10, ns will be equal to 0 to 1. So, this will be the general electronic configuration for such kind of the compounds. This is general electronic configuration. n-1 d can accommodate maximum of 1 to 10 electrons and the configuration will be ns 0 to 1. Now, these are known as the transition elements we have discussed earlier. So, the d block elements are known as transition elements. These are known as transition elements. Now, what will be the next property of such kind of the compounds? The next property of the d block elements are they will form the colored compounds. Next property is they will form colored compounds. They are forming colored compounds only because one characteristic is exhibited by the d block elements, that is paramagnetism, because they exhibit paramagnetism. Next property of the d block elements are that they will again show the variable oxidation state. So, they will show variable oxidation state. They are going to show the variable oxidation state. One more feature of the d block elements are that we have written the characteristics from here. One more feature of the d block element is that these elements can exist as metals, non-metals and metalloids. So, these are some of the characteristics of the d block elements we have discussed here. So, in our today's lecture, we have gone through characteristic of S, P and D block elements. Now, we are left with the properties of F block elements that we will continue in our next lecture. Thank you so much and have a nice day.